Alrighty, so we are starting section 10.2, which is graphing y equals ax squared plus bx plus c. Now this is continuation of what we've been talking about, where we're graphing quadratic functions and equations, and y equals ax squared plus bx plus c is the standard form for quadratic functions and equations. So there's things you have to keep in mind when you are graphing your parabola. One of which is being able to identify the vertical minimum value and the vertical maximum value. So for instance, if I were to draw a parabola such as this, and it's going up in a positive direction, this means is that if we were using our standard form y equals ax squared plus bx plus c, and we see that our graph is in an upward direction, this means that our a would be greater than 0, which also means is that a would be a positive number. And if I am asking for the vertical minimum or vertical maximum, in this case, this one would be a minimum, because this is the smallest measurement that it can be on the graph for the x-coordinates. And at this point right here, which we learned from the other day, is called the vertex. That also identifies our minimum value. Looking at a maximum value would be something that came in a downward direction, which means that a in the graph would be less than 0, which means is that a would be a negative number, and our maximum value would be pointed at the vertex. And so it's easy to remember, if a in any of our quadratic equations or functions has a positive number to it, we know that it has a minimum value. If our a is negative, then we know that it has a maximum value. If we look at our second directions here, it talks about our graph being narrower or wider than our apparent quadratic equation, which was y equals x squared, and the narrower graphs come from when the absolute value of a is greater than 1, and we called that the other day a vertical stretch. And the wider ones, which show up as a is greater than 0 but less than 1, which means it's a fraction or a decimal, and we called those the other day a vertical shrink. So today we will be paying more attention to these 3 steps. There are 3 things that we are trying to look for when we are trying to graph a quadratic equation with the standard form y equals ax squared plus bx plus c. And first thing we have to find is the axis of symmetry. And we can find the axis of symmetry by using the equation x equals negative b over 2a. Now, if we look at trying to find the vertex, which is in number 4, we know what our x-coordinate is because we just found it when we identified the axis of symmetry, then all we have to do is substitute in that x value into the current equation that we are trying to solve to get the y value. If that does sound confusing, I will do some examples to hope that'll give it a more clear explanation. For number 5, they're asking to find the y-intercept, which can be identified through c, and the coordinates for this point are 0, c, and that is where it lies on the parabola. So let me scroll down here and let's take a look at our first examples. So our first examples for A is y equals negative x squared, and B is y equals negative 1/4 x squared plus 3x plus 1. So let's look at example A. In order to first solve for our quadratic, let's write out the general form. Y equals ax squared plus bx plus c. So first off, what I'm going to try to do is let's find what our a, b, and c are. A, b, and c. So here our a equals negative 1. B equals 0 and c equals 0 because there's no b squared or c in this equation. So using our equation to find our axis of symmetry, I'm going to use the x equals negative b over 2a, which that equals 0 over negative 2, because our a is negative 1, 2 times negative 1 gives us negative 2. But as we simplify it, we find out that 0 divided by negative 2 gives us 0. So our axis of symmetry is x equals 0. And now what we do to find the vertex, we know the x value is 0, and now all we have to do is substitute in this value here into x, and we plug in the 0. That means y equals 0, so our vertex is at 0, 0. That one was kind of simple, so let's try one that's a little bit less simple. For b, we have y equals negative 1/4 x squared plus 3x plus 1. So again, I'm going to use this form here. So let's try to find our a, b, and c. A equals, b equals, and c equals. A equals negative 1/4. B equals 3, and c equals 1. Now, next is I'm going to attempt to find the axis of symmetry. So I'm going to use my x equals negative b over 2a, substitute in my b, which would be 3, but I have the negative here. So that's a negative 3 over 2 times a negative 1/4. So negative 3 goes here. 2 times a negative 1/4 gives me a negative 1/2. I have a negative divided by a negative. I can make those positive. And 3 divided by 1/2 is 6. So my axis of symmetry is x equals 6. To find my vertex, I know what my x-coordinate will be 6. Then all I have to do now is substitute in my 6 for my x and solve for y. So I got y equals negative 1/4 over 6 squared plus 3 over 6 plus 1. I am going to do some multiplication where 6 squared is 36. Divided by a negative 1/4 will give me negative 9 plus 18 plus 1. So y equals 10. So my vertex would be 6 comma 10. These examples, they're asking to state whether the equation has a minimum or maximum value. Then once we identify that, we must find that minimum or maximum value of the parabola. So let's look at A. A is 2x squared minus 16x plus 4. So for what we remember from before, if A is positive, that means it's going in a upward direction, and when it's going in an upward direction, we get a minimum value. For B, it's f of x equals negative 4x squared plus 24x plus 13. A happens to be negative, which is a negative 4, and because it's negative, it's going in a downward direction. And since it's going in a downward direction, we can say that it has a maximum. It's going to have a maximum value. So since we found what those are, now we must find the minimum or maximum value of the particular parabola. Now, if trying to find the minimum or maximum value of the parabola sounds a little long-winded, all you're doing is trying to find the vertex of the parabola, which we've done in previous examples. So first off, we're going to do it just like the same thing. I just want to find what my A, B, and C are. For A is going to equal 2, B is going to equal a negative 16, and C is going to equal 4. Now, as I go into finding the vertex, first I have to find the x value. The x value is with that equation y equals, or x equals, negative b over 2a. I'm going to substitute in my negative 16. Because I have the negative here with the b, that's going to be a positive 16 divided by 2 times 2, which gives me 4. And then 16 divided by 4 equals 4. So I have my x value, so now I can write in my vertex and 4 comma. Now all I have to do is substitute in the value 4 into our original equation. So I'm just going to write f of 4 equals 2 over 4 squared minus 16 over 4 plus 4. And 4 squared gives me 16, times that by 2 is 32. 16 times 4, I have the negative, so that gives me a negative 64, and then plus 4. And bringing those all together, I get a result of negative 28. So my vertex would be 4 comma negative 28. We found out that it's a maximum value for B. Now I have to find the vertex. So let's go for that. So let's find our A, B, and C value. So A is negative 4, B is 24, and C is 13. Go back to our equation, x equals negative b over 2a, which then gives me a negative 24 over 2 times a negative 4, which gives me a negative 8. Negative 24 divided by a negative 8 gives me a positive 3. So, looking for the vertex, we got 3, comma. We don't know what our y value is, but we can substitute in our 3 into the original equation, and solve for it. So let's do that. So we got f of 3 equals negative 4 over 3 squared plus 24 over 3 plus 13. And as you look, 3 squared is 9 times a negative 4 will give you negative 36. 24 times 3 gives you a plus 72 and plus 13. Put those all together, we find out that our result is 49. So our vertex is 3 comma 49. The last thing in my examples is we are going to graph our quadratic equations. Now there's 3 things that I'm looking for in order to solve or be able to graph the quadratic equations. One is we need to find the y-intercept. Second is we need to find the axis of symmetry. And we also need to find the vertex. So with that being said, we can first figure out what our a, b, and c are. We know that a equals negative 2, b equals 12, and c equals a negative 7. So our y-intercept, from what we saw from the beginning directions, is 0 comma c. So with c equaling negative 7, we know that our y-intercept is going to be at coordinates 0 comma negative 7. To get the axis of symmetry, we're using our x equals negative b over 2a, and that equals negative 12 over negative 4, which that gives us 3. And so we have x equals 3, and the vertex is 3 comma, we don't know, but I can plug it back into the original equation. So negative 2 times 3 squared plus 12 times 3 minus 7, which then gives us negative 18 plus 36 minus 7, which gives us a result of 11. So our vertex is at 3 comma 11. So if I were to graph this, I am making a xy plane at the moment. So if I were to, first thing I'm going to do is I'm going to find my y-intercept. So it's at 0 comma 7, so 1, 2, 3, 4, 5, 6, 7. I'm going to move my graph a little bit down. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So it's right about there is where our y-intercept is. Let me raise it up just a tad. And our vertex is at 3 comma 11. So I got 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. And this stinks. It's not tall enough. So I'm just going to just eyeball it and just going to tell you that it's at 3 comma 11. I do apologize that I can't show you the entire graph. And it's just a matter of connecting those points to make the graph. At this point, I'm not concerned about your artwork. I'm more interested in this portion of your solution much more than your artwork in graphing the function or equation. I'll do one more. So this one is y equals 2x squared minus 8x plus 7. So I'm going to find my A, B, and C. And A is 2, B is -8, and C is 7. So our y-intercept, right off the bat, I know is 0, 7. Our axis of symmetry, again, we're going to use this equation. We have a -8 and we have a negative b, so that gives me a +8 divided by 4, and that gives me our axis of symmetry is x equals 2. So when I go for the vertex, I know that our x value is 2, and I'm going to substitute in 2 for our x in the original equation. 2 squared minus 8x plus, oh, I'm sorry, this needs to be a 2, not an x. And so I have 2 squared is 4, 4 times 2 is 8, minus 16 plus 7. So our y equals a -1, so our vertex is at 2, -1. Now when I make this graph, this one probably would be a little better. It fits the screen at least. And so our vertex is at 2, -1, so that's where our vertex is. And our y-intercept is at 0, 7, so 1, 2, 3, 4, 5, 6, 7. And now it's just a matter of connecting these points. And there you go. That is our graph of our quadratic equation. Hope this video helped you out and clarified anything you needed for 10.2, and I will see you next time. Thank you.